So this is the second video for Math 120. And now we'll just review some basic things about lines, in a little more detail than what we did in the previous video, where we found the intercepts of lines. But this time I'm going to talk about how you build the equation of a line and how to think about parallel lines and perpendicular lines and all kinds of fun stuff like that. So pretty basically, somebody asked you, say in Walmart, like, how do I get a line? How can I determine a line? Well, to get a line, you need to know a point on the line and kind of a direction or a slant, right? So I've just kind of sketched out here, take a point, draw a slant. Or I could have taken the same point and draw something like a line with a slightly different slant or a slightly different direction, if you like. Or I could have chosen another point, say Q, and drawn a line like this. So to determine a line, you only need to know a point on the line and a particular direction or slant of the line. And that's called the slope in more precise, fancy terms. So lines are completely defined by a point. I should say a point. We kind of clear it up. Point and a slant or direction, if you like, called the slope. Now, how do you get this? How do you know, the slope or slant of a line? How can you compute that in a practical way? So we can compute the slope of a line by knowing 2 points on the line. So if I have 2 points, say x1, y1, and x2, y2 that are on the line, then the slope of the line, which is usually denoted by the lowercase letter m, is the difference in the y coordinates divided by the difference in the x coordinates between the 2 points. So let me just kind of sketch that out to you. So say here, if my first point is down here, x1, y1, and my next point's up here, x2, y2. The slope is the ratio of the difference in the y coordinates, y2 minus y1, to the difference in the x coordinates, which is here, this distance, x2 minus x1. And that ratio measures, and in ways we'll make more precise later on, in some sense, how steep the line is changing or how quickly the line is changing in some sense. So just to kind of foreshadow that, we can also think of the slope as a rate of change. And this m is really the change in y, in the y coordinates, as a ratio in relation to the change in x coordinates. And some people call this the rise of the line over the run. So the line is rising vertically as it's running horizontally, and that ratio of rise to run measures how, in some sense, quickly or steeply the line is changing. And this, in abstraction, doesn't make a whole lot of sense, perhaps, but once we deal with some more concrete examples and do some a little more detail, we'll explore this idea again. So maybe the easiest equation to write down of a line is the so-called point slope form. So if we're given a slope m and a point x1, y1 on the line, we can get the equation of the line by saying, just by using this definition of slope that I just gave you above. So as follows. If xy is any other point on the line, then by the definition of slope, y minus y1 over x minus x1 has to be equal to the slope m. And so y minus y1 equals m times x minus x1. And that's the point slope form of the line. So let me just highlight that for you. Oops. There we go. Somehow like a more, even though the point slope form is usually more easy to obtain from the information like that comes with a line, it's kind of tricky to graph the line from the point slope form. So if you don't know the graph a priori, if you don't know it beforehand, and you only, but you want to, get the graph from the equation of the line, the point slope form maybe isn't the easiest form to do this. The easiest form is the slope intercept form. So given the slope m and the y-intercept b, so slope and a point on the line, which happens to be the y-intercept, then the equation of the line in terms of this data is given as follows. Is y equals mx plus b. And we can get this equation easily from the point slope form, this equation here above star, as follows. Oops. So just take in star, in this equation star, the point to be the point x1, y1 to be 0b, to be the y-intercept, and then we get the equation y minus b, and star, this equation in star becomes y minus b equals m times x, and you just rearrange that, and you get y equals mx plus b in a really nice way. Okay, so that's just a very, and this equation is very convenient for getting the graph, because if you have this slope intercept line, you can draw the graph by just plotting the y-intercept and then plotting the slope appropriately, the slant appropriately, as we were kind of playing with at the very beginning here. Okay, so we're just going to play with this form of the equation for a bit. So examples. So find the slope and the y-intercept for the following lines. So this one's really easy because this is already, so this equation is already in slope-intercept form. So we see that the slope here, so which is the form number y equals mx plus b. So the m is 4/3, the slope, and the intercept b is minus 32. So that's really quite straightforward. Now the next equation isn't in slope-intercept form. So we have to first put this in slope-intercept form to be able to read off the slope and the intercept in the way that we just did in this first example. So we need to put this equation, to write this equation, in slope-intercept form. Oops, sorry. And to do that, we can just solve for y. So you get 3y equals 19 minus 2x. And so y equals 19 over 3 minus 2/3 x. And if you like, I can put things in the right order. And we have minus 2/3 x plus 19 over 3. And so now we see here the slope is minus 2/3, and the intercept is 19/3. So the slope, m, is minus 2/3, and the y-intercept is 0, 19/3. So I think I should probably, to be completely formal, I should write the y-intercept as a pair. I think the homework wants you to do that. Sometimes I get lazy because the y-intercept is the only that matters is the y value, but probably should stick with writing it as an ordered pair because I think that's what the online homework wants you to do. Okay, so now we get a little bit trickier here. So line passing through, line passing through 1/3 and 4/9, right? So now we have 2 points on the line, neither of which is the y-intercept. We don't even have anything about the slope. But remember, we can find the slope from knowing 2 points in the line. Back up here, right? So if we have 2 points in the line, we can find the slope. So what we're going to need to do here, this is a little bit more involved. So we need to first find the slope, and then we're going to have to find the point slope form using one of the points in the line, and then convert that into the y-intercept form to get the y-intercept. Or we can maybe even, well, we'll see what there's a faster way we can also take. So, all right, so let's first find the slope. So we get m is equal to, okay, so we'll call this here, we'll think of this as x1, this guy is y1, this guy is x2, this guy is y2. So 9, so maybe I'll write the definition first. So y2 minus y1 over x2 minus x1. So you get 9 minus 3 over 4 minus 1 is 6 minus 3, which is 2. So the slope is 2. Okay, and now we can get the point slope equation of the line. So I can use either point for this point slope equation. Let's just use 1, 3 because the numbers are smaller than 4, 9. So we get y minus 3 over x minus 1 is the slope 2. So we get, and I'll just rewrite this if you want in the intercept form, and maybe that is the fastest thing to do. So y minus 3 is times 2, sorry, equals 2 times x minus 1. And so this is y minus 3 equals 2x minus 2. And so solving for y, we get the intercept form. So you get y is 2x plus 1. So the slope we've said is 2. And we see the y-intercept is 0, 1. Okay, so that one's a little more involved because you start off with 2 points. You have to find the slope. And once you find the slope, to get the intercept, right, you have to find the point slope form. But we kind of found the point slope form and then used it immediately, or did some computations immediately to get to the intercept form by solving for y. So that I think is the best thing to do. Okay, so now we're going to do some sketching. Okay, so a line of the slope, first we want to sketch a line of slope minus 4/3 passing through the point minus 2, 1. And then we're going to sketch this guy. We'll worry about that later. So let's do number 1 first. And this you can kind of be a little bit rough if you don't have grid paper. It's hard to say exactly where things go. So, but maybe we can be. So, well, we can be smart about this. So minus 2, we want to figure out first, sorry, the point minus 2, 1 is somewhere along here. And then it should have a slope, right? The line should have a slope of minus 4/3, right? Now you could kind of try to eyeball like, well, -4/3, you know, where is it going to be on this axis? But that's, you know, it would be very, very rough. We could to just kind of try to eyeball it without a proper grid. So what we can do, and I would suggest we do to make a more accurate graph, is to find also the y-intercept, because then we'll have 2 points on the line and we can just connect them. So again, kind of like in the last example, we find the point slope form. So is y -1 over x minus -2 is -4/3. So you get, oh, sorry, y -1 over x plus 2 is -4/3. So we have x -1, oh, sorry, y -1 is -4/3 times x plus 2. And so you get y -1 is -4/3 x minus 8/3. Right? If you kind of expand that, so you get y is -4/3 x plus, so you have to add 1. Wherever you add 1 is adding 3/3, so it's actually going to be -5/3. So now we know this second, so now we have the y-intercept, right? The y-intercept is -5/3. Let me just clean that up a bit. Right? So the slope we know is -4/3. The y-intercept we now have is -5/3. So -5/3 is a little more than -1, so maybe it's down here. And now you have 2 points on the line. And we can easily just draw a pretty good sketch of the line by connecting these 2 points. So that's how I would approach it if you don't, you know, have a precise grid. So instead of just trying to eyeball, well, what would a slope of -4/3 look like? Find the y-intercept using the point slope form. And then you have, once you have the y-intercept, you can plot the y-intercept, and then you have 2 points on the line. You just draw the line connecting them, and that gives you a good rough sketch of the line. Okay, now what about for number 2 here? For point 2, we have 2x minus y equals -3. So we start with this equation. And what I would suggest we do is put this equation into slope-intercept form. Okay, so by solving for y. So we get y equals 2x plus 3. So the slope is 2, and the y-intercept is 3. Okay, so this we could probably draw a fairly easy graph. We can also, if we want to, find the x-intercept. So to make the graph, so to have another, just like we did before, to make the graph, rather, you know, than trying to guess what a slope of 2, what slant that exactly has without a grid, it can help to find another point in the line. So to make the sketch, let's find another point in the line. Say, let's find the x-intercept. So, okay, so we set that to find the x-intercept, we set y equals 0 and solve for x, and this isn't too bad. So you get the equation -3 is equal to 2 times x. So you get x equals minus 3/2. So now we can draw a nice sketch. So the y-intercept was, we said was 3. The x-intercept is minus 3/2, so it's like minus 1.5. So it's like here. And we can draw the sketch by just connecting the two dots, if I can even do that. Not the best artist. So, and then I get a nice sketch of a line, slope 2, y-intercept 3, and you can kind of see how it compares to the previous one. So notice that, let's zoom out here for a second. So a line with a negative slope, like the first example, a line with a negative slope moves down into the left, and the line with a positive slope, the second example, moves up into down to the right in the first one, and the positive slope moves up into the right. And just make sure that you can see that's a negative number. So it's, and that's something that we'll see we'll be able to explain a little bit better why that's happening when we do a little bit more analysis later. So positive slope moving up and to the right, negative slope down and to the right. So just take a minute to go through this. I think on the homework you have these graphing tools, so you may not have to, you can probably draw, you'll be able to draw much better graphs, but I think it's good to see how you do this by hand if you don't have a grid. And it's nice because it reminds us of the going from point slope to y-intercept, and then this example here where we can start with the y-intercept, but we need another point in the line. It is a good review of our discussion of x-intercepts, which is a natural other point to find the line. Okay, so let's talk about the last thing to talk about in this section about parallel lines and perpendicular lines. So parallel lines are two lines that never meet, right? So if you think about what that means, if two lines never meet, then their slant is identical. And the way we say that mathematically is that parallel lines are distinct lines of the same slope, right? The two lines are parallel if and only if they have the same slope. And that's what this is saying here. We're going to ignore the case of a vertical line. It's a bit tricky at this point to talk about what the slope of a vertical line actually is. We'll get to that in a moment. So one of our class mascots is kind of here. Let me maybe make sure he's comfy, but he's getting a little antsy. It's almost time for him to have his dinner. So, okay. And two perpendicular lines. Perpendicular lines are lines that meet at right angles, right? Now, this is a little harder to show, but two lines are perpendicular. Again, ignoring the case of vertical, we won't worry about vertical and horizontal lines for a moment. But two lines are perpendicular, which neither vertical nor horizontal, if and only if the product of their slopes is -1. So two lines are perpendicular if their slopes are negative reciprocals. So this is what this is saying. I'll just say that in a slightly different language. So the slopes are negative reciprocals. Okay, so here's a nice little exercise. So find lines that are parallel and perpendicular to the given line, y equals 1/3 x minus 2, which pass through the origin. Excuse me. Okay, so we look at this line. This line is, for us, is in slope-intercept form. Now, we don't care about what the y-intercept of this line is, because to find the lines that are parallel or perpendicular, the only information we need is the slope. So, but we can read that off the equation easily. The slope is m equals 1/3. So a parallel line, so if a line passes through the origin, right? So let's just think about what that means for a second. So if a line passes through the origin, then its y-intercept is 0. So now what I want to do to solve this problem is find a line with the same slope, parallel line, that's y-intercept is 0, and then one that's perpendicular with a negative reciprocal slope whose y-intercept is 0. That's it. Then we're done. So we've just translated this problem into the language of intercepts, which we understand, and we know how to write down an equation of a line with a given slope and a given intercept. So we should be able to solve this problem. Okay, so a parallel line passing through the origin has the equation y equals 1/3 x. So same slope, but the intercept is 0. So it's like there's like a plus 0 here that you're not seeing, that we won't write. Okay? So that's just, we know the intercept is 0, the slope has to be the same, so 1/3 x. And the perpendicular line passing through the origin is, okay, so the y, so slope is a negative reciprocal, so it's going to be minus 1 over 1/3 x. Again, plus 0, the y-intercept is 0. So remember what I said about dividing by a fraction, you invert and multiply, so it's minus 3x. And there, okay. Okay, so again, just using our definitions, figure out what does it mean to pass through the origin. That means the y-intercept is 0, and then using our knowledge of y-intercept slope form to write down the equation of the line from the definition of parallel and perpendicular. So just putting it into language where we can solve the problem. That's what a lot of math is. Okay, so now we want lines that are perpendicular and parallel to the line y equals 2x that pass through a different point, 2 minus 3. So this one is going to be a bit trickier because this one will have to use point slope form, right? We're not going to be able to immediately say what the y-intercept is. We're not given that information as we were in the previous problem where the information was in this back to the line passed through the origin. We knew the intercept was 0. This one we're not given that, so we have to work a little harder here. Excuse me. So the slope of this line y equals 2x is 2, right? We can just read it off the equation. So the point slope form for the equation of a parallel line passing through 2 minus 3 is, okay, so y minus 3 over x minus 2. Parallel means it has same slope, so equals 2. So that's the point slope form. And I can just, if you want, solve this. So y plus 3 over x minus 2 is 2. And I always like putting things in slope intercept form, but you could leave it like this, I guess. So you get y is equal to 2x minus 4 minus 3. So you get y is equal to 2x minus 7. So that's the parallel line to the same slope as 2x, but passing to the point 2 minus 3. So parallel. So for the perpendicular one, we do the same thing, but remember the slope for the perpendicular one has to be a negative reciprocal. For the perpendicular line, we have y minus 3 all over x minus 2. The negative reciprocal of 2 is minus 1/2. And you can kind of keep going if you like. We can finish this off. So your y plus 3 or x minus 2 is minus 1/2. So y plus 3 is minus 1/2 x plus 1. All right, so if you multiply minus 1/2 by x minus 2, you get minus 1/2 x plus 1. And so I can rearrange this, and you get y is minus 1/2 x minus 2. All right, so I hope this wasn't too boring. This is probably largely a review, but we had a long Christmas holiday break, and probably it's your mind's not been thinking about lines, factoring in math and intercepts, so it's good to kind of start slow, get the juices flowing again. And this will be enough for the first week, and then we'll starting. I promise we'll get into some more serious calculus and learn some new things that you haven't seen before fairly soon. So thanks for tuning in, and again, any of this is unfamiliar, or you need more examples or discussion, I'm more than happy to help you in the live session. Okay, thanks for tuning in.